Currently, it's not possible to animate the precipitation effects within the atmosphere editor. All other areas of the atmosphere editor, typically you can animate the sliders over time. If we take a look at the atmosphere editor. But the rain and snow effects are not part of that. Changes you make will not create keyframes. So if you want to, say, create a delay for snow or rain, that is something you're going to have to set up within the material. So we're going to take a look at that right now. What I'm going to do is create rain. I'll go ahead and add that in, and I'm going to increase the fog boost a little bit, and go into the sky fog and haze and just increase the haze a little bit. Go over to the sun, actually the light tab, and I'm going to darken the scene a little bit, just because when we've got rain, rainy day, it's going to be less light. There's going to be more cloud cover. I'm not going to worry about adding clouds at the moment. And then I'm going to take the ambient light color and darken it and desaturate. So that we can see the rain a little better along by the ground, I'm going to reset the ground material. And if we hit F11 on the keyboard, we can open up the timeline and we can scrub through. For now, what I'm going to do is increase the size of the droplets, make them bigger, so that we'll be able to really see them without having to render very large frames. And then I'll go ahead and increase the rain strength. Also, I'm going to go to the main camera and turn off the auto exposure. And that will make it a little easier to see some of the changes that we're making. In this case, if you see, the rain strength will increase the fog boost. So now that the auto exposure is turned off, we can know that that is actually increasing the fog level. So if we need to decrease that a little, we can, to kind of balance that out. I'm going to turn down the turbulence a little to about 0.3. And let's just take a look at the rain at this point. I'm going to go ahead and set it up. Render, I'm just going to use my user settings, which is basically based on the final settings, except if you go into the anti-aliasing options, I've got a couple of changes for the geometry in contrast threshold, and I'm just using 3 and 9 for the min and max. I'm going to go ahead and render it to the screen, and I'm just going to set it up to 1000 for the width. So here's the render so far. We can see streaks of rain from the motion blur for the raindrops that are close to the camera. What I'm going to do is open up the post-render options and just increase the exposure by, we'll go ahead and do 0.4. And I'm going to select no because I don't want it to be animated. Okay, so what we want to do is set up a little bit of a delay for the rainfall. Motion for the particles is generated before the timeline starts. So even at earlier frames, I could take it over to frame 0. I'm just going to do a quick preview render. We'll still see the same amount of rain. So it acts as if there's always rain. So if we want to have a few second delay, let's say about 2 seconds before the rain starts, we need to modify the material. And we can't just take the transparency over time and just immediately switch it over between that time frame, because what's going to happen is the entire volume, no matter where the rain is positioned, will just show up, and it'll look a little weird. So what we want to do is have the rain come in based on altitude. So first what we need to do is edit the material. So right click, edit material, and I want to reset this scale. Right now it's set to 0.1. To make things a little easier, since we're going to be working with true altitude, I'm going to set this value to 1. And if you want to keep the bump production that is built in to manipulate kind of the shading a little bit in the rain, what we can do is just take the bump scale and change that from 3 to 0.3, and then change the depth to 0.2. And that'll basically equal it out to the way it was. So what we're going to be manipulating is, because there's two different options that need to be either removed or changed to higher values. One is the global transparency. We're going to need to have it set at 100% in order for it to not show up. But there's still one remaining value even if we set this to 100%. So just right now I'm going to render it with the global transparency at 100 just so you can see the other value that's still in there. So it might be a little difficult to see, but there are streaks, and maybe if I just modify and do some post effects, we can see that a little better. You should be able to see those streaks better now. So we still have something that needs to be removed, and that's the highlight and the specular value. So what we need to do is remove that at the same time we remove the transparency. So those functions need to be linked. What I'm going to do is just show you how that's going to work out. Change the highlight and global intensity to 0. Re-render. And now you can see the raindrops are completely gone. So those are the changes we need to make over time. So I'm going to set this intensity back to 18% so that we can extract it and get the values in the function editor. I'm also going to take that global transparency and set it to 80 the way it was before. So we're going to go to the highlight and we're going to drive it with the function. That's going to give us our constant value, the equivalent percentage to -1 to 1, which is the output. We could also change this from a parametric output to a standard output so that if we actually wanted to type 18 in and have that be the value, we could set that up too. But what I'm going to do also is go to the transparency and extract the global transparency. I'm not going to use variable, I'm just going to use the global. It should be a little easier to set up. So these are our final values. What I'm going to do is add a constant node for the highlight, which is going to be -1. So that's going to be no highlight at all. So we're going to start at -1. And I'll go ahead and put that on top just for now. And I'm going to add another constant number, and making sure that we have a constant number for a constant node, and set the value to 1. And this is going to be our final, our start value. And the same thing with this -1, that is our start value, not ending. So the start value for the global transparency is 1, which is fully transparent. So what I want to add in is a blender node. And we're going to start with input 0 on the -1 for the highlight, and input 1 on that -0.64. Add another blender, and we're going to input 0 on that 1 and input 1 on the 0.6. And we connect those. So now what we want to do is adjust the time, or use the time to modify the blender, and just change the ratio from 0, which is that starting point, all the way up to 1, where we get to the partial transparency. Same thing with the highlight, going from no highlight to a little bit of a highlight. So what we're going to use for the direct control of this is going to be the altitude input. I'm going to go ahead and bring that input node over to the right over here, and I'm going to change the altitude type to absolute, and then we can change that to meters. And I'm going to start just by connecting these blenders to the altitude. And we also want to make sure that we're going in to each of the blenders and turning on the clip ratio 0 to 1. That way we're not going outside of these defined values that we have in our constants, because otherwise it's going to go way beyond those values depending on the ratio. So at the moment we don't have any motion set up for this, and it's just going to take this direct altitude and we're just going to see sort of a gradient throughout the material. What we need to do is offset it, the altitude, because we don't want to start with the default value. And we're going to need to offset it by basically the height or the starting point off frame. And then we're going to have that change over time. So what I want to set up is adding a filter. We're going to change it to offset and connect that to the altitude. And once it's offset to 1, it should be fully visible. All of the rain should be visible throughout the scene. So just to check and make sure it looks okay, I'm going to go ahead and render it out at this point. And that looks good to have everything at the values, their default values for the material, so we're seeing the rain. So now what we want to do is use the time to adjust that offset, and then we can have the rain start to come down. I'm going to go ahead and save this at this current point. And I'm just going to call this rain delay. And it should be a fairly small file, so I'll go ahead and save the steps along the way, and so include them with the training so you can load them in. So what we're going to do now is go back to the atmosphere editor and go into the function, which we can left click on this transparency if we're in the transparency tab. And what we need to set up is a map filter. So I'm going to add a filter, set it to map, and now we need to set up our time. So say we want a 2-second delay. I'm going to type for the lower value 2, and then we need to also set how long it's going to take for the altitude to change and move down. So we kind of want to match the velocity of the rain for the most part, at least around that. We can start with, say, a value of 4. So for 2 seconds, between 2 and 4, we'll have this being offset and moving. So we're going to set the lower value to -20. And the upper value where we had the offset of 1 looked good. We can go a little higher if we need to. Maybe we could bring it up to 2 just to make sure. We could also bring it up to 20. That would be a total distance of 40 over 2 seconds, which actually might be okay. Otherwise, you can just use an upper value of 1 or so. So this is going to control our offset. We also want to make sure we're going to clip the out of range values, and then we're going to connect that to time. So once it reaches 2 seconds, or well, it'll start at -20, and then once it starts going between 2 and 4, it'll go from -20 up to 20 for the offset. So we can connect the offset to that map, and now we should have a delay set up. And we're also going to vary it a little bit using the instance seed and particle seed. And that way it's not completely uniform. We can have a little variation. So I'm just going to scrub about 1 second in and just do a quick preview render and see how that's looking. And I don't see any rain. Keep in mind that if you do have anything connected to the collision density, if you have collisions turned on, and you're controlling, say, a material with collision density input, these particles should still be registering, and their collisions will register. It's just we can't see them. So unfortunately, since we can't animate the atmosphere, this is really the only way to do it at the moment, except for setting up your own particle system and object. So now I'm going to scrub through to about 2 seconds and see if we can start seeing the rain come in. And not quite yet. So it should be starting at around 2 to show up. And keep in mind there's a little distance between where it starts and then where it enters the frame. So it does need to kind of fall in. So now at 3 seconds, we see the rain start showing up. So let's go ahead and go about halfway and see if we can get an in-between frame to show up. Or kind of have it coming down. We can just start to see that rain starting. And scrub through a little bit more. I'll go ahead and just render that. So basically over about a second, we'll start to see the rain start to come in from the top of the frame and reach the bottom. And then we can adjust the overall speed of that by changing the outputs within that map value. But for the most part, it's very uniform. So if we want to have it be a little more varied so it's not this straight line, we can have it come in at different times. Go to the atmosphere editor, edit the raindrop material, and I'm just going to go in through the alpha. And what we're going to do is add an input node object instance particle seed. This is going to generate a vector coordinate for every single particle. Each individual particle will have its own vector output. Now what we need is a numeric value. So what I'm going to do is just add a math node, so right click, math node, vector operations, decomposer 3. And we can just connect to one of the axes, x, y, or z, to get a value. And it should be varied throughout every single instance, still on every axis. What we do need to define is the output. We don't want to have it going all the way to 1,000, because what we're going to be doing is offsetting the altitude. So a value of 5 to 10 should be good. So I'm going to do -5 and 5. And then what we can do is add another offset before the time offset. Add filter, change to offset, and then connect it to, just connect it to the z. So now it would be a variable for each individual particle. So we're going to see that some of them, because we raised the altitude a bit, it will start coming down a little bit faster. If you only want to work with negative numbers, you can go -10 to 0. Otherwise, we can just have it coming down a little sooner. If I just scrub back a little bit and do another render, we'll take a look. So now we can see it's a lot more gradual, having that come down. Now, because the altitude is a variable amount, there's a possibility of having a bit of a gradient along the bottom. There is an easy way to get rid of that. So what I'm going to do is just close this out, and I'm also going to save and create a new version of this. All right, we'll go into the material, edit the function, and what I want to set up for the offset is first I'm going to add a filter node floor and set it to 0. And since we're cutting everything out before that with the blender, it doesn't really matter too much, but what we want is, instead of having values between 0 and 1, immediately once it goes higher than 0, even 0.0001, we can make it jump up to 1 immediately. So that way there's no gradient. And we can do that with a math node and seal. And that'll immediately make it jump up to 1 once it reaches a value higher than 0. Because this math node will raise the values to the highest, the next highest number, or the highest integer, the next integer up. And then the floor, if you were to use floor, does the opposite, and it'll bring it to the lower integer. So in this case, we would keep it at 0 until it reached a value of 1. So either way you could do it. You could either have it jump immediately to 1 or stay 0 until it hits 1. Either way would work. So now we can look at the differences between the two. So just the previous frame and the next frame up. Just seeing that we're getting rid of that gradient. Unless you want it. If you want to have it fade in a little bit more, you can get rid of that seal function, the math node. So that's just a cool way you can set up a little bit of a delay if you want to have the rain start coming in at a specific time rather than just having the rain already start. If you find that the displacement or the delay is not quite matching the velocity of the rain and the material just doesn't quite look right, then the easiest thing to change is going to be the map function for time and setting the upper value. So 2 being basically our start time, where we're going to start seeing the rain pretty much. There's a little bit of offset, but it does generally tend to be the start time that we really see it. What we can do is just lower, if we needed it a little faster, we can lower the upper value, say to maybe 3 or 3.5. And if it's going too fast, we can raise it up, say to 5, or raise it up a little higher. Because keep in mind, with that output range at -20 to 20, really once it hits 1, it is going to show the rain. So it might be twice as fast as the actual time set up. So we can also take that upper value and change that to 1 if needed, or 2 a little lower. There's different ways we can modify it and make adjustments. Now, if you also wanted to have it sort of move in from one side of the scene to the other and start moving across as if a cloud was coming in or a storm front was coming in, we could also offset the altitude with a noise node. And we'll do this along the x. Go ahead and edit the function. And what I'm going to add is a noise and set it to math patterns. And we'll do step. We'll do step smooth. And I'm going to change the wavelength on the y to 0 and on the z to 0. That way we've just got the x-axis. And then we can just adjust the scale and how large we want that variation to be. We could also do even a tooth rectangular, or not the triangular, and then clip one side. And there's different ways we can work with it. The step smooth should work all right. We'll go ahead and scale that up a little larger. And then what we want to do is use this to further modify the offset of the altitude. And I'm just going to offset the origin just a little bit. And we need to set up a map filter. And our value should be -1 to 1. So lower value -1, upper value 1. And then we're going to set up our output range and how much we want to offset it. So I think what I'm going to do is -20 for the lower value, maybe -10, and then 0 for the upper, and we'll see how that works out depending on what direction it's going. Connect that to the map, and then we want to offset. So create a filter, set it to offset, and connect that to the map filter. And I'm just going to pull back the focal length a little so we can see a little more of the scene and then take a look. And you can see that gradual step right there. It is smoothed. If you want to have something a little more linear, then we'll have to use a different type of control. Depending on how quickly it comes down, one thing we could do is just really increase the map output a lot higher. I think what I'm going to do is edit the material, make that step a little larger, offset it by -1, and then go to the map. Let's try -30 and see how that looks. So I've got the camera pointing up a lot more now. And you can just see that curve there and the angle that it's coming in. And I'm going to go ahead and scrub a little bit further into the timeline and see how that's looking. I'm also going to go into the atmosphere a little and reduce the glow effect. And darken the sky a little bit. You can see that gradual incline there. I think what I'm gonna do is modify the material just a little bit more and decrease the size of the step. And that might work a little better with the velocity of the rain. And there you can see that wall coming in. So scrub a little bit further. And we can see that moving along. It's still a little curved there. So another thing we could do is just use the vector itself to modify this. So what I want to do, and I'm just going to go ahead and save this version first, just in case. And then what we'll do is use a math node decomposer 3, connect it to the position, and then instead of using the step with the noise, we can connect this to the X output and then use the map from here. Okay, so if we take a look at our precipitation area, it's 30 meters. So what we'll do is we'll take -30 to 30 for the lower and upper of the input range, and we'll set that to let's try 0, -20. And it's still not quite how I want it, so I think I have a different idea what I could do. And what I'm going to do is add in a sphere and just lower it below the ground plane. Or we could just have it up a little bit just so we can see it for now and turn off the render of it. And I'm going to go back into the atmosphere editor. And I'm going to change this to -1, or actually we'll do -2 for the lower value, and 2, and then we'll do -30 for the lower and 0 for the upper. And then I'm going to add input external dependency and set it to that sphere's position. And then we can connect this to it. And I'm going to set it to meters. And now we should be able to move that around and move the sphere. And if we animate it, then we should be able to control that wall. Might not be enough because we are pulling down the altitude over time. So we just need to make a couple of tweaks. And actually there is one thing I forgot to do, and that is to offset the material position from the sphere position. So what we actually need to do is go into the material, add a blender node, set it to subtract, and we're going to select the position, and then we're going to subtract that external dependency, and then connect that to the decomposer. What we can also do is take that lower value, set it to -40 for the output range, and then make sure we're also clipping the out of range values. And that should work to create a nice wall. And there we can see the cutoff there. So what we could do is move that sphere and animate it along the ground, just moving it. And then we can have sort of a wall of water coming in. What I could also do is maybe go into the map and increase the range just a little bit. And then change the output just a tiny bit. And what I'm going to do is just move this sphere, turn on auto keyframing, and move about 6 seconds in, and then move the sphere across the screen. And then I'm going to turn off auto keyframing. I'm also going to go and increase precipitation area a bit and change the raindrop size so that we can see them better. Increase our light in the scene so pick up those drops a little better. And let's see how that looks. And it doesn't look like the sphere is animating properly. It looks like we don't have a keyframe for the beginning. So all I need to do is just take, and it looks like it's probably because I created the sphere at a different point in time. So I'm just going to take that first keyframe and move it over to 0. And now it should move across. And I'm going to go ahead and adjust the sun. Just a little bit. Raise the ambient light a little. And at this point it's actually getting a little difficult to control because we've got so many things interacting. I think the best thing to do is actually, instead of using the time function for the offset, I'm just going to connect it to the map for the position and basically set up the same output, so -20 to 20. And then we can connect that offset and disconnect this other one. And we won't have the beginning delay anymore, but it'll be controlled by that position input. So we really won't need it, because we don't want to have too many delays. And it looks like because I'm clipping it, it's not quite working properly. So I'm going to set the upper value to 0, lower to -20, and also the upper to 0. And that way we shouldn't go too far out of bounds, and we're going to see how that looks. Otherwise what we can do is just extend that output range if we need to clip it, because it might be going a little too far out. But it looks like that's actually working pretty well. You just have to see how quickly the rain is falling down, whether or not it intersects with the material too much. It looks like it should work okay. We can always extend the range Right now it's just at 4 meters, but we can shorten it or raise it. We can also increase the speed or change the position of the sphere. But that looks like that should work out okay. And I've renamed this now that I've disconnected from the time from rain delay to rain wall, because now we have a nice wall of rain controlled by this sphere. So wherever we position it, and just on the X in this case, we can move that wall of rain. And here's a render facing the wall of rain coming towards the camera. I've made a couple of changes just to the raindrop size and the post settings so you can see the drops a little better. I also added turbulence in order to distort that edge so it wasn't completely straight. And I can show you the turbulence setup. And if you want to load it in, it's going to be named Rainwall 2. But if we take a look in the atmosphere editor, edit the raindrop material, what I did was added turbulence node, connected it to the position, and then I've offset it, or set the origin of the turbulence to be the sphere, and that way it moves with it and not through the turbulence, because that's going to be weird with the way the material's set up, since we're not adjusting or controlling the creation of the particles. We're just adjusting basically the transparency, and since they're already there, it'll look really weird moving through the turbulence. So by setting the origin to the sphere, it'll move with it, and that edge will stay kind of fixed for the most part. I've got the largest feature set to 71, amplitudes around 8.8, combination mode multiply, harmonics is 0.32 about, scaling 0.36, repeats on 4, and then I'm offsetting before the decomposer and after the subtract for that. And then you can get a preview. If you click on the map, you can see what used to be a fairly straight line is now curved and jagged. So you can make changes to the turbulence, and then if you take a look at that numeric output, you can see in the function node preview just how much distortion there is. And then you can adjust the scale to see the overall area and just how much distortion or scaling there needs to be. So that works out pretty well. I'm just going to go ahead and save that. It's kind of a way you can get around not being able to animate the atmosphere by having a control object and not only setting delay but also controlling a wall of water falling. So this can also be used for snow. And there's just one last thing I want to show you, and that has to do with when you have a large amount of rain or snow, and you've got basically the drops showing up really close to the camera, falling in front of it in some cases. And if it's too great of an effect, which it sometimes can be, I just want to show you really quick how you can just add one more simple connection to this to make sure that anything really close to the camera will either be more transparent or just won't render, period. You can get a little more of a modification out of it. What we're going to do just really quick, edit the material. And we want to do this after the current function. And what we're going to do is set up another blender. And we're going to connect input 0 to the fully transparent constant 1, and input 1 to the blender. And I'm going to add an input node, distance to camera. I'm going to set it to meters. I'm going to add a map node, and we can reset it by just clicking map from the list if it's duplicating a previous map that was selected. And what I'm going to do is set the lower value to, let's say, 1.5, and then we'll set the upper to 2. And we'll go ahead and connect that. And I'm going to create another blender and doing the same thing, input 0, going to no highlight, input 1 to the more advanced output and setup that we have. Connect the highlight to that blender. We also want to connect the transparency to that other blender. And then we can connect these ratios of the blenders to this new distance output. We're going to clip the out of range values. And now we shouldn't have anything rendering until it's 1.5 meters from the camera. And then this blend, basically a half-meter blend from 1.5 to 2 for the distance. So you can adjust that range further if needed. And in my preview render, I've still got some very large ones showing up close to the camera, and that's mainly because I've got the drop size turned up to 5, just so we could see them. But I just want to show you how you can really easily just go into the function. And one thing you could do too, to make it a little quicker so you don't have to modify more than one value, is just extract both of these, add a filter, offset, and we're going to offset whatever our fade distance is going to be, let's say 0.5 meters. We're going to connect that to our lower range and then set the upper to that. So now we can just modify one setting and then have that fall off automatically. So go ahead and set that to 3. We can also publish the parameter if we just want to access it in the material editor. And now those large drops in front of the camera are gone, and they're not going to render because they are 100% transparent and they have no specular value. And there's a slightly better render of it, even though we still have those giant raindrops. So I am going to go ahead and render just one with a normal drop size. And there's a slightly better render of it. So some neat ways you can modify the precipitation and weather effects. Of course, that works both ways for the snow. Either rain or snow, you can use these setups and functions for both. And I'm going to go ahead and save this as rainwall 3 with the camera function and the distance to camera setup.